Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 9.2, which is going to deal with conditions for parallelograms. So we're going to continue our look at parallelograms today, and what we're going to do today is talk about the conditions that allow us to prove that a quadrilateral, a four-sided shape, is in fact a parallelogram. Now, today is going to feel extremely similar to what we did yesterday or the day before, where we talked about the properties of parallelograms, where opposite sides, opposite angles are congruent, that consecutive angles add up to be 180 degrees, and that diagonals bisect each other. So keep those in mind for parallelograms from yesterday for today's lesson. Now, for today, we have one learning goal, and our learning goal for today is that you will be able to use properties to prove a quadrilateral is a parallelogram. So we're going to talk about these four different concepts that allow us to prove that a quadrilateral is, in fact, a parallelogram. So with that said, let us begin talking about our stuff today. Our first theorem that's going to allow us to prove a quadrilateral is a parallelogram is going to be this. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if we know that opposite sides are congruent, so the top and bottom is congruent, and the left and right sides are congruent to each other, like such, then I know that my quadrilateral is a parallelogram. So yesterday, we were saying if you have a parallelogram, then opposite sides are congruent. Today, we're saying if we know that both opposite sides are congruent, then we have a parallelogram. So if we're starting with the sides, what do you suppose is our next one? It is the angles. So my second theorem states if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So that means if opposite angles are congruent, then I know it is a parallelogram. So that means if I know this angle is congruent to this one, and this angle is congruent to this angle, if I know both sets of those are congruent, then I know it is a parallelogram. So as long as you either know that opposite sides are congruent or opposite angles are congruent, then you know you have a parallelogram. And to kind of back that up, again, just remember consecutive angles, like these two, are going to add up to be 180 degrees. These two, and these two. And then we have one more theorem that we're going to take a look at today, and let's go ahead and move this up. Our final theorem that we're going to take a gander at is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So that means we need to know that this segment is congruent to this segment, and that this segment is congruent to this segment. If I know that this is congruent to this, and this is congruent to this, okay, that tells me that the diagonals bisect each other, and therefore we have a parallelogram. So as long as you know one of these four things, then you in fact know that you have a parallelogram. That is going to be what we do today. So for 9.1, it was using the properties to find measures. Today, we're going to be asked to find measures to prove that we have a parallelogram. Or they're going to tell us what x or y, z or w equal, and then confirm that it gives us a parallelogram. So with that said, let's go ahead and move on to example 1. All right, example 1 is going to ask us to find the measurement that would make the quadrilateral a parallelogram. So for this first part, we have to discover what the measurement needs to be that would give me a parallelogram using the four things we just talked about. Opposite sides are congruent, opposite angles are congruent, consecutive angles add up to be 180, and the diagonals bisect each other. All right, so if we look at A, so for A, they tell us that angle K is 50 degrees, and they want me to figure out what L needs to be to make this a parallelogram. So if I know K is 50 degrees, what does L need to measure? Now, angles K and L, are they consecutive? Are they next to each other? Or are they opposite of each other? Because they are consecutive, because they're next to each other, means that they need to add up to be 180. So to figure out what L needs to be, we're just going to take 180 and subtract by the measure of K, which in this case is 50. So if I do 180 minus 50, we get 130. So that means that L needs to be 130 degrees for these to be consecutive to add up to be 180, which then tells me that element K would be a parallelogram. So that means the measure of angle L needs to be 130 degrees. And that's our answer for part A. Now, for part B, if we look at part B, they tell us that angle B is 126 degrees, and that angle D is the measure that we need to discover that would make this a parallelogram. So D is what we need to find the measure of. If we look at angle D and angle B, these two angles right here, are they opposite of each other or are they consecutive? Because they are not next to each other, but they are opposite of one another, that means that they need to be congruent. So if B is 126, it means that D also needs to be 126. So that means the measure of angle D needs to be 126 degrees. And that is our answer for part B. All right, to finish up example 1, we have two more parts C and D, that we need to go through and address, and then we'll move on to example 2. So if we look at C, they tell us that the side length TS is 22 units long, and we need to figure out how many units long UR needs to be, so that way we have a parallelogram. Now the thing that we know about sides in a parallelogram is that opposite sides have to be congruent. So because these two sides are opposite of each other, if ST is 22, that means UR also needs to be 22. And that's our answer for part C. All right, lastly, for part D, part D is going to be very similar to part A because angle W is 118 degrees. And they want me to figure out the measure of X that would make this a parallelogram. W and X are consecutive angles because they're next to each other. They're not opposite of each other. Because they're next to each other consecutive, that means that they need to add up to be 180 degrees. So we're going to take 180 and we're going to subtract it by what we know W is, 118, to figure out what X needs to be. So if we do 180 minus 118, we get 62. So that means the measure of angle X needs to be 62 degrees. And that is going to be our answer for part D. And that is all that we have to do for example 1. Alright, so that should feel fairly familiar to what we did in section 9.1. It's just kind of adjusting the wording instead of using the properties to find the measures. This time we're finding measurements that make them a parallelogram. So that is it for example 1. Next we're going to go ahead and jump into example 2 on the next page. Alright, example 2 is going to ask us to show that each quadrilateral is a parallelogram for the given values of the variables. Now, if you notice for parts A and B, okay, for part A, it's going to look at side lengths. Part B is going to look at angle measures. And our goal is to go through and show that we have a parallelogram when x equals 7, y equals 4, z equals 11, or w equals 4.5. So let's go ahead and just focus on part A first before we move into the other ones. All right, for part A, they give us the quadrilateral ABCD, and they tell us that x is going to equal 7 and y is going to equal 4. So that means we don't have to go through and figure out what x and y are and then plug it in. Okay, we're not trying to find the measure, we're trying to prove that this is a parallelogram. Now your quote-unquote proof for today is not a two-column proof, it's just plugging in x and y to verify that opposite sides are in fact congruent. So if we take x first, okay, the two things that involve x are BC and AD. Let's go ahead and look at the top here, BC. BC is x plus 4, and we're going to plug 7 in for x. So for BC, that means we're going to have 7 plus 14. And if we do 7 plus 14, we end up with 21. So that means BC is 21 units. Next, if we look at for AD, because that's my next one that has x, so AD, its expression is 3x. That means we're going to do AD equals 3x. That means we're going to do 3 times 7. And 3 times 7 is going to give me 21. So that means I know that AD is 21 units. Now, at this point, I know that BC and AD are the same measure, which they're 21 units long. While, yes, we know one set of opposite sides is congruent, we need to show both sets are. So our next step is to take y, and we're going to plug it in for both of these expressions. So we're just going to first look at AB because it's on the left, which is this 5y minus 4. And we're going to plug 4 in for y. So AB is 5y minus 4. So that means 5 times 4 minus 4. And if we go ahead and pull out our handy dandy calculator, we do 5 times 4 minus 4, we end up with 16. So that means that AB is 16 units. Next, we need to go through and look at, for the side length, CD. Now, CD is 2y plus 8. So that means we're going to take 4 and plug it in for y. So it's going to be 2 times 4 plus 8. And again, if we just use our handy-dandy calculator, 2 times 4 plus 8 is going to give us 16. That means we know CD is 16 units. So by plugging in 7 for x and 4 for y, do I in fact know that this is a parallelogram? I do, because I know both pairs of opposite sides are in fact congruent, because BC and AD are congruent to each other because they're both 21, and AB and CD are congruent to each other because they're both 16. Therefore, they're both equal to each other. So for part A, I do know in fact that ABCD is a parallelogram. So for parts B, C, and D, you are going to do the same thing, where you're going to take the value for the variable that they tell you, you're going to plug it into each expression that includes that variable, and then confirm if it does in fact give you a parallelogram. So with that said, I am going to take a look at part B next. So for part B, they tell us that Z is going to equal 11 and that W is going to equal 4.5. So we were given angles F, G, H, and E, and they give us an expression for each of them. So our goal is to plug in Z and W into each of these expressions. So we're going to take 11 and 4.5 and plug them in. And see if we know that either opposite angles are congruent or that consecutive angles add up to be 180. Now, because we're going to look at all 4 angles, the most straightforward one would be to see if opposite angles are congruent. So first, let's focus on Z because that's the first number. So we're going to take 11 and we're going to plug it into any expression that involves Z. And the 2 that involve Z is F, which is 9Z plus 19, and H, which is 11Z minus 3. So let's first take a look at F, this 9Z plus 19. So angle F, 9Z would be 9 times 11 plus 19. So what we're going to do is use our calculator. We're going to go through and do 9 times 11 plus 19, and we end up with 118 degrees for the measure of angle F. 118, sorry. So that means angle F is 118. All right, next, the other expression that involves Z is in fact H, and for H, it's 11Z minus 3, so that means we're going to do 11 times 11 minus 3. So angle H, we have 11 times 11 minus 3. If we do 11 times 11 minus 3, we end up again with 118. So that means the measure of angle H is 118 degrees. Alright, so I now know that F and H are 118, so I've confirmed my first set of opposite angles are congruent. And if we look at E and G both involve W, not Z. So that means we are done with plugging in 11. And next we're going to take 4.5 and plug it in for both of these angles. So first up is angle E, which is 12W plus 8, and they tell me that W is 4.5. So we're going to do 12 times 4.5 plus 8. So if we do 12 times 4.5 plus 8, we end up with 62 for the measure of angle E. So that means angle E is 62 degrees. All right, all that is left is G. So we're going to take the 14W minus 1, and we're going to plug 4.5 in for W. So angle G is going to be 14 times 4.5 minus 1. So we do 14 times 4.5 minus 1. Oh, I did 4 negative 5. We end up with 62. So again, we have confirmed that another set of opposite angles are congruent because we know that G and E are 62 degrees. So, in short, can I say that this is a parallelogram? I can, because I know that F and H are congruent because they're both 118. And I know that E and G are congruent because they're both 62. Therefore, confirming that this is in fact a parallelogram. And that is our answer for part B. All right, so that is going to be the gist of how you do example 2. Now, parts C and D are going to carry the same idea, where we're going to take the value for, in part C's case, A and B being 2.4 and 9, and plugging it in for A and B. And then for D, they tell me X is 6 and Y is 3.5. So you're going to plug that in for the different diagonal segments. And your goal is to go through and confirm that these are in fact parallelograms. Now, we could go through and do this together. Hopefully by this point you feel pretty comfortable with it. I am just going to kind of summarize what to look for if you were to do parts C and D. First of all, it is done on my completed notes if you are looking at those for reference. So all the work is done there and would show you what you would have to do. For part C, they tell me A is 2.4 and A refers to these two side lengths. So that means you would plug 2.4 in for both and see if QP equals RS. Next, after you would figure out if these are congruent to each other, is to take 9 for B and plug it in. So you would plug 9 in there and 9 in there. And your goal is to figure out what the measure of angle Q and the measure of angle R are. And because these are consecutive angles, because they're next to each other, your goal would be to figure out if both of these add up to be 180. Not to see if they are congruent because they're not opposite each other, but because they're consecutive, you need them to add up to be 180. So you'd figure out if QP is congruent to RS, and then if angle Q plus angle R equals 180. All right, and then for part D, because we're dealing with the diagonals, the goal for part D is to confirm that the diagonals bisect each other. So that means you would need JN to be the same measure as LN. So if we took X being 6, you would figure out if I plug X or 6 in for X, for 2X plus 2, and 4X minus 10, that these two should equal each other. They should be the same measure. And then if I took 3.5 for Y, if I plug it in for 6Y plus 1 and 8Y minus 6, that MN and KN should be the same measure. So like I said, you can reference my completed notes to see how those are done and to verify that they are parallelograms. Both of these are in fact parallelograms. So you're just going through and confirming that they are. So I will leave those for you. Again, you can reference my completed notes to see how those are done. Again, if you have questions, you can always ask me next time you see me or via email. I'll be more than happy to walk you through it. Otherwise, that is it for our notes today on section 9.2, conditions for parallelograms. And that is it for our video today. So if you have any questions, as always, let me know. Please reference the completed notes for parts C and D if you would like to see how they are done. Otherwise, that is it for today. Thank you guys for listening, and I hope you have a great day. All right, bye.